Okay, so let's do a quick pointer review covering just all the things that we've, or at least the important things about pointers that we've covered so far. So, as a review, I can have an integer pointer and I declare that with an asterisk in the declaration. So, a lot of times you'll see this with the asterisk immediately after, just to sort of to further clarify that the type here is a pointer. That's what that asterisk means. It doesn't mean multiplication. So I'm just going to call this pointer for now. And let's also create an integer array. And I'll call that ARR of, let's call it nums. And we'll say that there's 10 nums there. Let's fill that array with some numbers using a for loop. And so nums II will be equal to, and let's just set it to the numbers 1 through 10. So it'll be II plus 1 because we're starting in 0 with our loop. And so we'll add 1 to that so that we start our numbers actually at 10. Or I'm sorry, at 1. So now I can print these numbers out. If I get the braces correct. And we'll print an integer there, and is equal to whatever the value actually is of that number. Oops. So first we'll put II so that we know what index we have, and then we'll print its value, which will be num II. So let's run this. Or let's compile it. And it looks like, not nums. So we'll change those and go back and compile again. And we'll ignore that warning for now since we know that we'll use it eventually. So this is how we would normally access it, the members of an array. But we can do all of this without actually referencing nums. If we change this to where let's allocate, or let's declare pointer after nums, and then we can say that pointer is equal to nums. Then, anywhere we have nums II, we can say pointer, or we can dereference pointer plus II. And I'll leave that to say nums in the output because that's actually what we're printing out. We're just using the pointer variable to do that. And you can see the output is exactly the same. Now, we don't just use pointers for integers. Another way they're useful is to use them with structs. So let's just say we have a simple struct with, we'll say a float, num, and let's say a character array. We'll just call it name. It's a simple struct. Obviously, if you're writing a real application, you would have more specific names, but that serves our purpose for now, so we'll leave it there. And since we're using a type def here, we're going to give the name of the struct at the end, so and we'll just call it pointer example t. And as a review, the type def here, type def and then a type assigns this name to the type. So we have pointer example t is the type now that we've created. That would be the structure. I could also say struct pointer example or something, and then use struct and that name as the type name. But now I can say pointer example t, and then I'll say call it my struct, and I'll initialize it. We won't go into right now how to change these values later. So we'll give it a starting value of, let's say, 42, and this needs to have some size to it, so we'll say that's 10 as well. And we'll say our example will be Arizona. So let's create another pointer, but this is going to be an example t pointer. And we'll set that equal to the address of my struct. And I can do this anywhere in the code. I'm just happen to do this with the initialization. In fact, we'll come back with void pointers, and I'll actually show you how we can use just one pointer to point either to the enums array or the structure we just created. So let's print our structure. That's going to be my struct. I'm sorry. Oh yeah, my struct. Num, my struct, name. And let's just double check that we initialized everything correctly. It's not an int. So it's a float. So we'll say, we'll do it at 2 decimal points. Okay, I know I didn't use struct pointer, but that's okay. And when I run this, you can see that I get the output I expect. Since that's a float, let's use a floating point number. I guess pi is a little too basic, so let's just say 12.34. That way we have it, actually let's say 5, because that'll give us an interesting example of how printf works. Now I'm going to copy this printf line, but now instead of printing it here, I'm going to use the variable to print it out. Here I'm going to use the pointer to print it out. So instead of my struct num, I'm going to use the pointer, struct pointer, and then I'm going to use the arrow notation instead of the dot notation to signify that this is the field pointed to by this pointer. Now the reason this works is because this is a struct pointer. If this was an integer pointer, when you try to use this arrow, I would get an error message saying that that wasn't correct, that it didn't know what that field was because an integer doesn't have that field. So there is some typing in the pointers. It expects to be pointing to something of that type. So when I compile that, and you can see I get the same exact result, even though I'm using a different manner to print it out. So it's one final example of a void pointer. And I'll call it void pointer so that in our code we actually see the name. I can actually use this to point to anything. So I can say void pointer is equal to nums. And let me take this print statement and instead of using pointer, I'll use void pointer. Now I get an error because it says the type is incomplete. When I dereference it, it doesn't know what to reference it, what type it is, so it doesn't know how to interpret the bits that are in that memory location. So for example, if this is a string, it needs to say, hey, there's characters here. If it's integer or if it's a floating point, it needs to know how to interpret what values are in that memory location, because there can a floating point representation is just bits. Same for a character, same for a string, same for an integer. So it needs to know how to interpret those bits, and so we need to tell it that this is an int pointer. And personally, I like to put everything in parentheses just to be clear. They're not expressly needed in that case. Actually, in this case, they would be, since I'm adding, it wouldn't know what to add to. And notice the error is gone, and I can print this out. I can also change a value using void pointer. So if I cast my void pointer to, or let's say that void pointer and I'm going to need another parentheses here, plus, let's say 4, and that's going to be equal to, let's make it 100 so it'll stand out. So now when I print this, or when I run this, you'll see that I've actually changed nums. And that's changed in nums. If I use nums, the nums array to print these out, I would get the same thing. Okay, so that's how we can access the integer pointer, and then in this case an integer array using void pointer. So now I'm going to make my void pointer equal to the address of my struct. And so let's take the same thing we did before where we printed it out, but instead of using struct, the struct pointer, we're going to use pointer example t pointer. Whoops, that shouldn't be. Okay, so here we have to. So we're going to cast it to a struct. I'm sorry, pointer example t, and then the name is of the actual pointer is void pointer. Okay, we'll do the same thing here, and just to make this a little neater, we'll move this down to the next line, and I'm missing the asterisk here. Now this asterisk is different from the one above. This asterisk is the dereference operator compared to the one here, which is actually saying that this is a pointer type. So let's run this. So it doesn't like that type name. I put that in the wrong place. So now I'm saying that it's a pointer type when I put it at the beginning. There it was actually expecting it to be multiplication, and then I was missing the expression before the multiplication. So by putting it at the end, that's when we specify that it's the type. So if I run this, you can see we get the same output that we did above. And let's put in a printf here. And then here, let's say that we're using void pointer. Okay, and so the thing to keep in mind is this void pointer can be set to any other pointer. But then when I use it, this part is fine because a void pointer has no type, so it doesn't care what type it's actually pointing to. It doesn't have a type. So I'm pointing to some memory, there's bits there, whatever they are, the void pointer doesn't care. But to actually use that, I've got to cast it back using this syntax here, and then I would include that whole thing typically in parentheses as well before I use it, just so that I don't have to worry about associativity and precedence rules. So this becomes a pointer example pointer pointing to the address that void pointer does, and then I can get each field individually. And void pointer is also the default type if I return an integer. I'm sorry, if I use malloc. So suppose I wanted to use assign some memory to that void pointer. So now I'm going to say void pointer is equal to, and this isn't ideal. I'm just doing this for an example, but let's just go ahead and say we're going to allocate 100 bytes. Okay, normally you would want to allocate a certain number of memory cells for a given type, but this is a void pointer. We're just going to allocate a bunch of memory. So now, if we treat that memory as a character, or I'm sorry, as a, let's do it as a character. So I'm going to dereference as a char pointer. Void pointer. And I'm going to say that that's equal to A. And why I'm doing this will be clear in a moment. Actually, anytime you have 4 lines of code that are all the same, you should think, hey, I should make that into a loop. So let's do that for I equals to 0. And we'll do 20 of these just to be on the safe side. And why will be clear in a moment, I think. And here I'm going to say void pointer plus II. And I'm going to wrap that in one more parentheses just to make it clear that I'm, if you can see where the matching parentheses are. So here I'm saying this is a character pointer. I'm casting the void pointer to the character pointer type, and then I'm incrementing it by II, and that's what I want to dereference. And then I can say A plus II to get consecutive letters. And just so that I have a little bit of safety, I'll say void pointer plus 21 is equal to the null terminator, so that I can treat this as a string now because this is a bunch of consecutive characters in memory. What that lets me do I'm going to print it as a string because, again, it's a bunch of consecutive characters in memory. So that's going to essentially be a string. So I cast it to a character's pointer. And let's see if that works. It does not. Okay, so it looks like that's probably all the same thing. Doesn't like that line 46. I have a quote here instead of. That's why. Okay, so let's fix that. And we're using malloc. So let's use this, include the standard library. And again, just because your code works, that doesn't mean that necessarily, or that the warning can be ignored. So here you can see we've allocated the letters through T, the first 20 letters. Now, an interesting trick I can do is I can look at this as an int, and I'm going to print the int in hex, and the reason for that is because that'll give me each byte will print as 2 hex digits. So we'll change that to an unsigned just to get rid of that error. And I need to dereference it now as well, because I'm printing an actual value. Whereas when I do a string, I want to print a pointer to that string. I'm telling it where to look for the start of the string. For an integer, I'm actually saying this is the value I want to print. So I've got to dereference the variable, or the pointer. If I print this, notice I get 44, 43, 42, and 41. And if you look at an ASCII table, the easiest one to get to is at ASCIItable.com, but any will work. And then you look at the actual hex value of A, you'll see that the hex value of A is 41. And there's 41. 42, it's B, 43, and 44. And you'll notice they are backwards, but that's because of the way the word spacing is. In memory, they're stored in that direction. If we added one int to this, notice we get 45, 46, so it prints the next batch as well. Again, though, there's 4 of these that are in a group, and that inside that group they're reversed, but this is the first 4, and the second 4. And you get 41 to A, 45 is E. And so you can use these void pointers to point to anything. In fact, you can use them to point to different things at the same time. Now, typically this isn't something that you would want to do, but it does have some interesting uses in cases like this where you could actually generate an ASCII table doing something like this. You can also check for the Indianness of your processor, and there's an example of how to do that on GitHub if you want to see it. And this isn't everything you need to know about pointers, but I think this is sort of the highlights. Again, make sure you're taking these examples and using them, changing them up a little bit, trying to predict what happens. And if you have any questions, let me know. I'll post this on the GitHub repo. It'll probably be under the last C directory, which is C4.